Hi students, welcome to the session. I am Dr. K. Varada Rajkumar, Associate Professor, Department of CSC, AIML, MLR Institute of Technology, Hyderabad. In our previous class, we learned about trees. In this class, we will learn about graphs, introduction to graphs, definition of graphs, and different terminology used in graphs. Overview of the presentation. In this class, first we see introduction to graphs and definition of graph. So after that, we discuss about basic terminology used in graphs, and finally we will see real world applications of graphs. Outcome of the session: at the end of the session, you all are understand basic graph theory concepts and terminology, and recognize and describe real world scenarios where graphs are used. So what is a graph? A graph is a collection of vertices and edges. It's a connecting pair of vertices. This we called as a graph. So for example, so there is a city 1, city n. Now, so these two cities are connected by many other cities. Okay. Now this is the, for example, this is the connection. So this is another connection. So this is the another connection. Now, how we reach from city 1 to city n here? Through some intermediate cities. So these cities we called as vertices. Now this connection between these vertices we call as edges. Sometimes we call these vertices as nodes also. So what is a graph? A graph is a collection of vertices and edges. So connecting, so pair of vertices. For example, this is the city 1, this is the city 2. Now this city 1 and city 2 is connected with an edge. So what is vertices? So vertices are the fundamental unit of the graph. Sometimes vertices are also known as vertex or nodes. So edges means, so edges are connect two nodes of the graph. Edges can connect any two nodes in a possible way. So how we represent a graph mathematically is a graph G equals to V comma E. Here V represents vertices and E represents edges. So for example, so consider this graph. So this is the city 1, city 2, city 3, city 4, city 5. So this is the city 6. So now in this graph, what are the vertices? Vertices are C1, C2, C3, C4, C5. Now edges are, so this is the C1, C2. C1 comma C2 is one edge. C2 comma C3 is another edge. C3 comma C4 another edge. C1 to C4, that is one edge. C4 to C5, one edge. C5 to C6, another edge. And C6 to C1. So these are the edges. I hope you all are understand the definition of graph. What is a graph? So graph is a collection of vertices and edges. So vertices means nodes, edges means connection between these nodes. Okay. Now we see so real world examples of graphs. Why we learn graphs? So this graph concept we use in many real time applications. So for example, so transportation system. In this example, we discussed that how to reach from so city 1 to city 5. City 1 to city 5. Now this data we represent in the form of graph. And social networks. Now we all are getting notifications from Facebook, Instagram. How we are getting the notifications? If one person is friend of another person. So this person have many other friends. So these are the P1 person, P2, P3. Now, so the first person will get the recommendation of P1. So how? So this P1 is connected with your friend. So you get the notification. So we say that so social networks also work based on graph. And internet. So in internet, there is some routing algorithms. In that routing algorithms, we use graphs. So now we see the basic terminology used in graphs. So first one is vertex. A vertex is a fundamental unit represented as a dot. For example, in our previous case, so this is the graph we represent. Now C1 is represented with dot here. C2 is represented with the dot. So now second one is edge. So what is edge? It is a connection between two vertices. If I connect, so C1, C2, C3. So now, so this is the edge. So this is another edge. So C1, C2, C3, C4. Now this is the C4. Now, so degree of vertex. So degree of vertex means number of edges connected to a vertex. So for example, this is the C5. So this is the C6. Now, so let us assume this is the graph. Now, what is the degree of C1 here? So number of edges connected to vertex C1. So how many vertices? 3. 1, 2, 3. So the degree of C1 is 3 here. Now, so what is the degree of C3? The vertices are 2 here. Okay. So path, a sequence of vertices connected by edges. Now, so what is the path from C1 to C3? So C1 to C2 and C2 to C3. So this is the path. So let us see types of graphs. We have different types of graphs. So null graph, so trivial graph, undirected graph, directed graph, connected graph, disconnected graph, complete graph, cyclic graph, directed acyclic graph, and weighted graph. So let us see one by one. Null graph. A null graph is a type of graph that has a set of vertices but no edges connecting them. In other words, it consists of only isolated vertices with no links between them. So for example, so this is the city 1, city 2, city 3. Now there is no connection between these three cities. Now this we call as a null graph. Null graph. So for example, A, B, C, D. So in this graph we have 4 vertices, but there is no edge. So this type of graph we call as a null graph. So next one, trivial graph. A trivial graph is a type of graph that consists of only a single vertex with no edges. So for example, this is the A. So how many vertices? Only 1. So this type of graph we call as a trivial graph. Undirected graph. An undirected graph is a type of graph where edges have no direction. So meaning the connection between any two vertices does not have a specific direction. So for example, A is one vertex, so B is another vertex, C and D are the vertices. So these 4 are the vertices. Now if I draw graph like this without any direction, now the path exists between A to B and B to A also. So this type of graph we call as undirected graph. So what is the undirected graph? Where edges have no direction. If you observe here, these edges doesn't have any direction. So this graph we called as undirected graph. So next graph is directed graph. So what is a directed graph? So directed graph is a type of graph where the edges have a specific direction. So for example, A, B, C, D. Now I draw a edge from A to B with some direction. Now the edge is from A to B, not from B to A. Now so B to D, D to C, and C to A, C to B. Now if you observe in this graph, we mention the direction. So this type of graph we called as directed graph, where edges have a specific direction. Here the direction from A to B only, not from B to A. So next one, connected graph. A graph in which from one node we can visit any other node in the graph is known as connected graph. In this graph, if you observe, we can reach from C to A, C to B, C to D. Similarly, from A to B, A to C, A to D via A to B and B to D. And from B, B to A, B to D and B to C via either A or D. So this type of graph we call as connected graph. So what is connected graph? So every node is connected with all the other nodes directly, or they are connected via a vertices. Okay. So next, disconnected graph. A disconnected graph is a type of graph where not all vertices are connected by paths. In a disconnected graph, there exists at least one pair of vertices between which no path exists. So for example, this is the A, B, C, D. Now A is connected with the B and C is connected with the D. Now if you observe, these two graphs are disconnected. Now so this type of graph we call as a disconnected graph. Complete graph. A complete graph is a type of graph in which there is a unique edge connecting every pair of distinct vertices. In complete graph, all possible connections between vertices are present. So consider this. So A is one vertex, B, C, D. So 4 vertices. Now A is connected with B, A is connected with D, A is connected with C. Similarly, B is connected with A, B is connected with D, so B is connected with C. Similarly, so D is connected with A, B, D. Now C also connected with all the remaining vertices A, B, D in the graph. So we say that this graph is a complete graph. So how we can say that? Cyclic graph. A graph containing at least one cycle is known as a cyclic graph. So for example, here A, B, C, D. Okay. Now if you observe here, cycle means if you start from a vertex and traversing through graph, and again if you reach the source vertex, so that we call as a cycle. So now if you observe here, if the source vertex is B, from B to D, D to C, C to B again, so this is a cycle. Similarly, you can reach from C to C also via B and D. Okay. And another example is, so this is also cyclic graph, A, B, C, D. If you observe, all are connected, so it is also we called as a cyclic graph. So next, directed acyclic graph. So directed acyclic means both, it is directed and acyclic. So directed means mention with direction, and acyclic means a graph doesn't contain any cycle, so that we call as a acyclic. So directed means each edge in the graph has a direction. So going from one vertex to another, there is no bidirectional edge. each edge has a one-way direction. Acyclic means the graph contains no cycles. There is no way to start a vertex, so follow a sequence of directed edges and return to the starting vertex. So consider this example: A, B, C, D. Now, so this is the edge from A to B, and this is the edge from D to B, and this is the edge from C to D, and this is the edge from C to A. Now, if you observe, so this is the A, consider as a starting vertex. Now, so how to reach the A to A? If you traverse to B, and there is no chance to traverse from B here. Similarly for B, there is no any other vertex is connected. From D, we will connect B, and there from B there is no edge. Similarly, from C we connect D. From C we connect A. A will connect. A is connected with B, and there is no path from B here. Similarly via D also. So this graph we call as a directed acyclic graph. So this graph is directed and there is no cycles. So this we call as a directed acyclic graph. So weighted graph. A weighted graph is a graph in which each edge has an associated weight or cost. This weight represents the value or cost of traversing the edge and can be used to model various real world scenarios where different paths or connections have different costs. So for example here A, B, C, D. Now, so these are the connections, edges. Now from A to B it is 5. So B to D it is 1. From A to C it is 8. From A to C it is 7. From C to D it is 9. Now these numbers 5, 8, 1, 9, 7. So these are the weights. Now this weight represents some cost to traverse from one vertex to another vertex. If you want to traverse from A to B, what is the cost here? 5. If you want to traverse from A to D, so this is the cost 8, and via the B it is 6 only. These weighted graphs we can use in real world scenarios. Okay. Now coming to summary of the session. In this session what we learn? We learn definition of graph. What is a graph? A graph is a collection of vertices and edges. So these edges will connect the vertices. So graphs are versatile structure used to model real world relationships. So understand and we discussed about basic terminology. So crucial for working with the graphs, like so what is a vertex, what is a edge, and what is a degree, and what is a path, and different types of graphs here. In next class we will discuss about how to represent these graphs. If you have any doubts, so place your doubts in the comment section. I will try to answer. Thank you.